Cyrille, your presentation on rapid non-intrusive geophysical methods surveying dikes.
Good morning, everybody. I will present to you today the results of a working program of the FloodProBE project entitled Rapid Non-Intrusive Geophysical Method for Surveying Dikes, Conclusions from the FloodProBE International Geophysics Workshop, Paris, March 2011. The presentation will show the main objective of this workshop in the context of the FloodProBE project. And the main objective of this workshop was to find a global agreement between stakeholders and geophysicists about the geophysical method to be used to in order to have a good or to improve the dike assessment. And the brief plan of the presentation will show the state of the art before this workshop and the main point of the workshop program, and finally the main results of this workshop. Before the workshop we have invited a lot of geophysicists from various countries, and these geophysicists have some experience, some skills in geophysical survey on dike. And we have considered all the main feedbacks of or outcomes from other projects, other connex projects concerning the geophysics and the flood protection system. And the main point was to consider the stakeholder requirements concerning these geophysical methods applied to dikes. So after this, during the workshop, we have shared the experience of all these participants, and we try to elaborate a global methodology for stakeholders. And we arrive at 4 main points. The first point is a common agreement between geophysicists and stakeholders on the global methodology to be used to contribute to the dike assessment with geophysical methods. The second point was a discussion concerning the risk versus cost. The third point was the importance of time measurement of carrying out some measurements on dikes at a different time. And another important point was the discussion between urban or rural context. So the workshop produced a lot of posters and abstracts coming from dealing with different case studies taken from Germany, Czech Republic, France, United Kingdom, United States, Netherlands, etc.
So Cyrille, could you stand on this side?
Oh yes, sure.
Because there is a camera there, and I think you're standing in front of the camera, which is making it difficult there.
Okay, no problem. And after this presentation of posters and abstracts, a work session between geophysicists and end users has been done for studying a concrete case study, typical case study in Dutch context, French context, or Czech context. A complete report was made about this workshop, and the abstract and posters are available on demand if you want, or perhaps soon on the website of FloodProBE. So the main results I just said is a common agreement between geophysicists and stakeholders. And this common agreement, to make a brief resume of it, brief abstract, is that we have to consider preliminary data, that are composed of historic study, local geology, visual inspection, topography, morphodynamic study of the dike. Then after you have all this data, you can perform the geophysical methods on dike. and measure the correct parameter to improve the assessment of the dike. And you have to correlate your results with the geotechnical testings. And you have to make this correlation, it's a required stage of the methodology. Then you can contribute, or you can make the dike assessment. Another main point of discussion was the geophysical survey that we can perform on, we can carry out on dike. The first approach for long dike stretch consists of making a first zoning where we measure a global parameter, physical parameter, that reflect the distribution of materials inside the dike. Then when this parameter locally vary, then we made a second zoning with a more detailed method like the electrical resistivity tomography method that gives a precise map, a precise image of the dike transversally or longitudinal to the dike. This approach is typical from a French context in the Loire River or other river in European Central. This approach is rapid, the cost is lower, but the risk to not detect a weak point is higher. The second approach, sometimes we call it the German approach, consists of measuring with a precise method like the electrical resistivity tomography the whole length of the dike, whatever its length. And it is this approach that is carried out in Germany and sometimes in France with EDF, Électricité de France. This approach is slow than the first one. It represents higher costs, but the risk to detect a weak point is lower. So we have to define also the concept of what is a cost-effective method. A cost-effective method, we have find more than 10 criteria for each method. We have discussed about the data processing and interpretation efforts that we have to be made for each method, the acquisition speed, the estimated cost per kilometer. We have discussed about the applicability and limitations in urban or rural context. And for each method, we present the added value of the methods concerning the type of dike that the method could be applied or the sensitivity to which parameter, to which physical parameter. And we have another point, important point, concerning the geophysical survey that has to be repeated in function of time, in function of water level variation or season variation. That is slightly different from monitoring that usually concerns a quasi-permanent survey of a dike for leakage detection. But it's just a question of a time scale. And the last main point concerned the discussion about urban or rural context. What is an urban, what is a rural context? So it's quite simple. When we have a dike in a rural context, the main conclusion is that all man-made structures inside the dike are a weak point for the dike. And for all geophysical methods, the urban context is a noisy environment for the measurement. And you can have to survey a dike in a rural context, but that directly protect an urban area, like this case study in Orleans. So we have made a lot of discussion of this kind in the report of the project. Just 2 slides, okay? And the main point, the main results of this workshop is the guidance produced in the context of the FloodProBE project, the guidance typically for stakeholders, a guidance that where the stakeholders identified his needs and with checking the available geophysical methods can select a geophysical approach. And guidance that present the interaction needed between geophysical investigation and geotechnical investigation. This guidance also presents a detailed table for method performances and cost evaluation. And he presents also an abstract for each method concerning its principle. And we discuss also the method applicability of each method. And the guidance is reinforced by 3 case studies, and 3 case studies concerning the Orléans payload site, Amber payload site, and Proa payload site. Okay, that's the last slide. This work was supported by the European Community's 7th Framework Programme through the grant to the budget of the FloodProBE project. This working program 3.2 report, including this work, is not soon, but just now, available since this morning on the website of FloodProBE. And here are the main contributors. Thank you.
Thank you, Cyrille. Just a chairman's comment, because I was involved in this myself. I think it's sometimes said that if you have 6 economists in a room, you will have 7 opinions. I think this is also true of geophysical practitioners. I think one of the achievements of this activity was to try to get at least a measure of consensus among people with very different opinions. Do we have a question for Cyrille?
Thank you. I'm a bit interested in the methods you used. Did you use electromagnetics or georadar? Did you try a broad number of geophysical methods?
We have studied all the possible geophysical methods in this work. We have studied all the geophysical methods in this guidance. So electromagnetic methods, airborne methods, etc.
Maybe there was some confusion. There was, apart from the pilot studies, there was no actual work done. It was a question of getting geophysicists together in the room and sharing their experiences and capturing all those and trying to get some agreement.
But did you agree on the method which is better in some terms, more accurate or more cost-effective? Like electromagnetic,
yes.
But it doesn't probe too deep into the dike, does it?
It depends of the dike constitution. If you have a dike with conductive materials, you will not use the...
You mean water?
Yes, for instance. No, you can use some methods, some geophysical methods sensitive to water content, and like the electrical resistivity tomography. For each case, you have geophysical methods.
So you cannot give a guidance which...
I think the answer to the question is that all these questions are actually answered in the guidance. So I would advise you to read the guidance if you're really interested. Thank you, Cyrille.